All right, I want to look at free body diagrams, and I may have seen this picture before, but in this case, I want to find the free body diagram here for the stick. I have the stick resting on a ball, and nothing is moving. What is the free body diagram for the stick? Now, to do that, I need to find all the forces on the stick. Of course, there's the force of gravity. It is always there. It's also then, other than that, I need to find the objects in contact with the stick. It looks like two objects are in contact with the stick. There's a point of contact here between the ball and the stick, and there's a point of contact here between the ground and the stick. So there's going to be a contact force from the ball on the stick and a contact force from the ground on the stick. And so in this case, these are contact forces. In my contact force model, I often want to break my contact force into a normal force and a frictional force that is perpendicular and parallel to the plane of contact between the two objects. And so in this case, because I have one of those surfaces is at an angle relative to the ground, when I set up my free body diagram, I prefer to have two sets of axes. One that's parallel and perpendicular to the ground, and then another set that's offset by the relevant angle in the problem. And this helps me assign the correct directions. It also helps me find angles when I need to find components of these forces, because of trigonometry, this angle right here is set up to be exactly that angle, and then I know that these other angles are all the same, and so when it comes to finding my projections, it's a lot easier to do. All right, well, let's first find our forces then. So we have the force due to gravity, and we know that that always points straight down, so I put that on my free body diagram. I give it a name. I'll call that F sub g. So now I want the contact force. Let's start with the ground. The surface of the point of contact is essentially the surface of the ground. And so there's a normal force of the ground on the stick that's perpendicular to that surface, pointing in the direction of the object, from the agent to the object. So that goes straight up. I didn't have my original axes very, very straight there. But so my normal force, I'll call that my normal force of the ground on the stick, is pointing up. Okay, so now I have a frictional force of the ground on the stick. In what direction is that pointing? Well, it's going to point in the opposite direction that the stick would move if there were no friction in the problem. That comes from our static friction model. So if there were no friction in the problem between these surfaces here, the stick would just slide then to the left. And so the frictional force has to be in the opposite direction of that motion. And so I have a frictional force of the ground on the stick then pointing to the right. And it's along, tangential to that plane of contact. Okay, so now I want to look at the other contact force between the ball and the stick. And so here, the plane of contact is set at an angle, which means the normal force and the frictional force will be perpendicular to that angle. So the first one is perpendicular to that plane, sorry. And so the first one, then, is perpendicular to that plane and points from the agent to the object. So that's the normal force of the ball on the stick, and that points along that axis. And so now I have a frictional force that's going to be perpendicular to that along the plane of contact between the two objects. But in what direction? Well, it's in the direction that opposing the motion of the object, assuming there were no friction at this point in contact. So what would happen if there were no friction at that point? Well, if there were no friction at that point, then the stick would essentially push the ball, and the ball would roll off to the right. And so what does that mean for the direction of the frictional force? We have to be really careful about what is the agent and what is the object. Remember, in this case, the ball is the agent. The stick is the object. So if the ball is rolling, and that means we have sliding at this point of contact, in what direction is the object moving relative to the agent? Well, the agent is, at this point of contact, is sliding off here, up and to the right. But of course, that's the agent, and that means relative to that motion, the object, in another color, is going to be sliding in the opposite direction. Now, it's sometimes tough to see because as the agent, the ball, rolls off to the right, the stick doesn't really move at all. It may slant down a little bit, but it's not moving off to the left in our frame of reference. However, the surface at the point of contact, the surface of the object is moving to the left relative to the surface of the agent. So that means the frictional force points in the other direction, which is then along the axis up to the right. So the frictional force points up and off to the right. The frictional force of the ball on the stick, ball on the stick, it points tangential to the surface, opposite the direction that the surface of the object would move relative to the agent if there were no friction present. And so if you saw the other video on the free body diagram, where we did the free body diagram for the ball, you could check, because you could identify Newton's third law force pairs and make sure that they're pointing in the opposite direction. But I wanted to, in this case, go through each force separately so we can work through the contact model to see in what direction the forces are pointing. And with a convenient sort of two sets of axes here, we can get all the forces in the right direction at the right angle relative to each other.